It's gonna be like 200 plus over 1.
I actually haven't lost it.
Me either. I just so proud.
I've lost at least
Oh, good. I've lost a single pencil so far.
I haven't lost a single one.
Okay. So what I'd like for you to add to this, or to write down first, is I want you to understand the ratios are used all over the place, and you had lots of examples, but they're written a few different ways, kind of depending on how they're used. So one way to write a ratio is to not use division and just say A to B. It's kind of weird. So yeah, you can write a ratio as A to B. You're comparing A to B. You can also write it using a colon. And then finally, the way we mostly write it is with a fraction bar. And here's something you want to remember. Always simplify your ratios. Always simplify your ratios. So for example, if I had 4 over 6, I could make that what?
2 over 3.
2 over 3. 2 over 3. And if you're not so good with doing that, we're going to do some examples and I'll work things out with you. All right, so I got a question here for you, or actually an example. It says, at a car wash, 18 freshmen and 14 sophomores. That's how I remember how to spell it. Worked first shift. We're going to do 2 things. Part A is I want you to find the ratio of freshmen to sophomores. Find the ratio of freshmen to sophomores. So if you're wondering, well, which one do I put on top? Which one do I put as the denominator? Well, you just pay attention to the order that they're asking, right? It says to find the ratio of freshmen to sophomores, so we're going to think freshmen over sophomores. How many freshmen do we got?
18.
18. How many sophomores?
14.
14. Is that a good answer? No.
6 to 7. Oh, wait, 9 to 9.
Yeah, okay.
Sorry.
Now, here's the thing. When numbers are more complicated, I want you to think about this. I'm going to rewrite 18 and rewrite 14 so that they have a common factor that I can divide on. So what I mean by that is we can rewrite 18 as 2 times 9, 14 as 2 times 7, and then what is 2 divided by 2? Well, 1. But does it show up anymore?
No.
It doesn't. So that's a way to simplify a fraction if the numbers are a little more complicated, is just rewrite it as factors, see if you've got common factors. So the ratio of freshmen to sophomores is 9 to 7. Yep, 9 to 7, 9 over 7. Let's do part B. Part B says find the ratios. Ratio. Find the ratio of freshmen to total students. Find the ratio of freshmen to total students. Go ahead and give that a try and see if you agree with what I think it's going to be. that? Yeah. 9 to 16. 9 to 16. All right. You got some time. It's nice. A proportion. A proportion is, you guys know what a proportion
A part of something.
Exactly. I have a question on the last one.
Yeah.
If we're trying to find the ratio of 9 to 12 students, why would we add 18 and 14? Because that's like freshmen.
is? Yep, so the total students would include, we're talking everybody at the car wash.
Okay,
So you can actually have freshmen be a component of the numerator and freshmen be a component of the denominator. Yep. Just because you have them in one spot doesn't mean they can't be included in the other spot. Yep. Mm-hmm. So, and you see this a lot, like with COVID, they'll say, there's 250 cases or whatever in Springfield. I think it's actually more than that. But how many is that out of the total population? What's the ratio? So you would count that 250 in the total population when you're looking at that ratio of COVID cases to total population. So a proportion states that two ratios are equal. Now, I gotta let you in on a secret. Have you guys heard of rational numbers?
Yeah.
What's the root word there in rational? And rational numbers are numbers that can be written as a ratio or written as a fraction. Okay? So I basically want you from here on out, whenever you hear ratio or rational, I also want you to think it's just fractions. So another way to think of this is a proportion states that two fractions are equal. And I'll go ahead and jump into the algebra for this. We're going to solve an equation. And our equation deals with h divided by 12 is equal to 17 thirds. Now, you can do this problem, a few different ways. You can actually just solve this kind of the way we know how to solve things, right? How do we undo dividing by 12?
Keep changing.
Multiply by 12. Just multiply by 12, right? That would get h by itself. And that would totally work here. But I guess I'll go ahead and let you in on a secret. If you have a proportion, which is a fraction equal to another fraction, you can get rid of the fractions. Okay? You can get rid of the fractions. It's a little bit overkill on this problem because it really is just straightforward, multiply by 12 and you're done. But for any proportion, you may multiply by both denominators to eliminate the fractions, or we'll say get rid of. We're going to quickly get to problems, if not today, tomorrow. We're going to get to problems where you're going to have to do that, okay? You're going to have to do that. Right now, you don't have to, but I want to show you that it works. Does that kind of make sense? So, what I mean by multiplying by both denominators is essentially, I'm gonna multiply by 12 to get rid of this 12, right? But what does the multiplication property of equality say?
Do it on the other side.
I have to do it on the other side. Well, I know for a fact that that's really all I have to do on this problem. But on more complicated problems, you're also gonna have to get rid of the other denominator. So how do I undo this division by 3? Multiply by 3. But what do I do to keep it balanced?
We'll throw it back to the other side.
So what happens is, watch this, do you agree that the denominators will go away? Because 3 goes into 3 one time, 1 times 12 is 12. 12 goes into 12 one time, 1 times 3 is 3. So they go away. And in this example, we're left with 3h is equal to, oh, help me out with your calculators. I think it's 114, but I could be way off.
204.
I think it's 114. Double check me.
204.
Oh,
17 times 12.
17 times 12.
Because 12 times
Oh,
10
the
is
set.
112.
Oh, yeah, I was missing a whole 70 in there. I think. Yeah. So what was it again?
204.
204.
And then divide by 3.
And then divide by 3. And what do we get h to be?
68.
68. So, again, multiplying by both denominators is actually the long way to do this problem, because we could have just multiplied by what?
12.
12. But I wanted to show you that it works. It works. Yeah, question, Tiger.
Not really a question, but I solved that by dividing 12 by 3, which is 4. And then that means 4 times 17 is what h is, which is 68. So
Yeah.
would it just be
So what you're talking about is proportional thinking, where you can see the relationship going from 3 to 12, and then you can repeat that relationship going from 7 to h. You totally can work problems out that way. And I'm not going to take off for you, or off on anything. But what's going to happen, Tiger, is we're going to have like h plus 3 or something like that. And you might have another variable on the other side. And doing those proportional, where you understand the way things are related, it gets more difficult to do because you also have to do the algebra with it. But what you just described is a perfect way to do it. Yep. So what Tiger was saying was, and this is true of any proportions, if you can find the relationships between numbers, they're going to repeat on the top as well. So like, do you guys agree that 4 times 3 would get you 12?
Yeah.
Well, because it's a fraction equal to a fraction, that would also mean that 17 times 4 would get us whatever the number is here. So it's just understanding the relationships of proportions. Let's try another, at least write it down before we have to leave. Have you guys solved proportions before?
We've heard of proportions, but we haven't
I
solved
think
them.
we solved them in grade.
Oh yeah?
I haven't done it since
I got
I don't remember.
that I can.
I'm not sure. Like real simple sort of things?
Yeah.
Yeah, like what we just did.
Yeah.
Alright, let's try. What happened? Let's try this one. You hike 5.5 miles in 2 hours. How far could you expect to hike in 7 hours? And we'll tackle this after lunch. But please hold your seats until my alarm goes off.